So, so far we have been talking about creating visual force pages, and for the visual force pages we have been using the standard controller. Now, what is the standard controller? Standard controller is basically before that, what is a controller? A controller is basically the set of logics which controls the behavior of the page, right? What will the page do? What actions will happen when I click on a button, or when I refresh the page and all that, right? That all comes from the controller, right? When we created the detail page, in that detail page we saw that we supply the ID in the URL, and automatically we can see the details of that particular record, correct? Then we created the list page, and then we had the options of clicking on next and previous and first, last, all those actions, right? What will happen when I click on the next action? All these logics are actually defined in the controller, all right? So far we have been working with the standard controller. Standard controller is the controller which is used by the standard Salesforce.com pages, all right? Because Salesforce already has got so many pages, so it has got controllers also for all those pages or for all those objects, right? Now, what we have been doing so far, we have just been using those controllers, all right? And that's the reason why we never needed to write our own code or our own logics. We were simply using that logic, which is pretty much defined by Salesforce. Now what we're going to do is we're going to create our own logic, all right? So we'll not be able to work with standard controller anymore. We'll have to start working with custom controller. Okay, the custom controller is basically a controller that you create. You define the logics inside it, you define the methods inside it, and then you call them on the visual force page. Correct. So now we are going to control the logics from our side. Now for controlling the logic, visual force cannot be used because visual force is not a proper programming language. It's just a markup language, right? So for writing the logics, I'll need another programming language, and that is Apex. Okay, so Apex is the programming language which we will use for writing logics, right? So the controller will be created using Apex, and then I'm going to call the controller on my visual force page. That's exactly what we're going to do now. Alright, so before we can actually get into the discussion of the controller and how to create a controller and how to call it on the visual force page, before I get into that part, we will just have a quick understanding or overview about Apex. Alright, so today what we're going to do, we are just going to understand basics of Apex, right? What it is, how it is written and all that stuff. So basics and a few syntaxes and the data types. This is what we are going to understand, so that once we start writing program, you guys can understand what exactly is happening, right? So as I said, Apex is just a programming language like any other programming language. I'm not very sure if you guys are aware of any other programming language or not, but it's pretty similar to the ones that we have seen, like C, C++, Java, C#, anything, right? Now in programming language, there is a very simple concept of defining variables, right? The same way in Apex also we have got variables. Now if there are variables, then there are going to be the data types as well. Okay, so what is a variable? Variable is something which can actually hold a value, right? Now since we have got the variables here, we have got the data types also. What type of data actually goes into that variable, right? So first thing that we are going to do is we are going to understand the different data types which are permitted in Salesforce or in Apex basically. Okay, so we are going to understand what all different data types are allowed in our Apex programming, right? So let's quickly understand about the data types. Okay, so here we are talking about Apex. So, let's understand what exactly Apex is. Apex is a strongly typed object-oriented programming language that allows developers to execute flow and transaction control statements. Right. Now the important part here There's definitely a programming language that allows you to control flow and transaction control statements. That's absolutely fine. Important thing here is that this is a strongly typed programming language. Okay. What does that mean? A strongly typed programming language means whenever you're defining a variable, you will have to define the type of the variable. Which means if I define a variable x, at the time of defining that variable, I also have to define type of the data that will go into that variable. Okay, so if I say x, if I say string x, only string values can be stored in that. Right? Some programming languages do not have this concept. Okay, there you can just define a variable and later on you can assign any value to that particular variable. But here in Apex and in these kind of programming languages, you have to specifically mention that this variable is meant for storing this type of data. It is for string, or it is for integer, or it is for boolean. So that's something that you need to mention. All right, that needs to be mentioned here. Okay, so that's the important part. Okay. Alright. So Apex enables developers to add business logics to most of the system events. It will actually enable a developer to add the logics to the events, including button clicks, related record updates, visual force pages. So these kind of system events, we can actually add logics to these things. We can add logic to a button click. We can add logic to a record being updated, a related record being updated, or a visual force space, right? So we can actually add different logics, all right? So that's about Apex. Because I said that this is a strongly typed programming language, which means every time you're defining a variable, you cannot just go and define a variable x like this. No, you have to define what type of data goes into this. So either you have to say this is a string. So if you define it as a string, it will only take string values. If you think that it's going to be an integer, you have to define it as an integer. Then it can only take integer values, right? So that's the attribute of a strongly typed programming language. Now, because we have to specify the data type for the variable every time, it's important for us to understand what all data types are allowed. All right. So let's go ahead and talk about the data types which are allowed in Apex. So right. So we have got in Apex, all variables and expressions have a data type that is one of the following. We have got primitives, we have got S objects, and we have got collections. Okay, so we have got primitives. Primitives data types are the normal data types that you use in other programming languages also, and they are basically used for storing single values. Right, like you want to store a string or you want to store a number. Okay, you can use primitive. S object data type is meant for storing complete records. Okay, now S object is something that you don't see in any other programming language. This is something very specific to Apex programming. Now, S object data type basically is used for storing records. So if I want to store a complete account record or a complete contact record, so a complete account record will have several values: name of the account, website, industry, number of employees, phone number, fax number. So many things. Okay. So S object is a data type which allows you to store a complete record. Okay, and then we have got collections. Now, what is collections? Collections is basically uh, the data type where we can store multiple values of the same type. Like if you want to store multiple numbers, then you need a collection. Or if you want to store multiple string values, then you need a collection. If you want to store multiple records, then you need a collection. Right? So that's go by the literal meaning of the word collection. All right. So these three data types are available primarily. So primitives are the ones which are used for storing single values, S objects for storing records, and collections for storing multiple values of the same type. Okay, so collection can be collection of primitives or collection of S object. Right. Okay. So we'll start talking about things one by one. So let's start with primitives. Okay. So primitives, as I said, are the common data types. Some of you might already be aware of the primitive data types. You might have used it in other programming languages. For people who have not used it or people who do not have much understanding about that, don't worry. So these are simple data types which are used for storing single values, individual values, right? So let's say I need a data type. Okay. Let's say I need a data type to store a country name. All right. The country name is basically a string. So I'll say country name equals US. All right. So this is basically a primitive, or I need a data type to store a number. So I can say integer I equals 65. Right. That's how it is. Okay. So there are quite a few data types, primitive data types available. Like we have a boolean can only store true or false or null. Okay. So boolean is a data type which can store only true, false or null. Then we have got a decimal, a number that includes a decimal point. So any number that includes a decimal point, which is not a whole number. Okay. So decimal data type can be used for storing a number with a decimal point. A double is a 64-bit number that includes a decimal point. ID is a primitive data type. ID can be used for storing any Salesforce.com ID. Now this ID data type is something that you don't see in any other programming language. This is something which we see in Apex, right? So this is primarily meant for storing the record IDs, right? Okay, so if you just want to store record ID of one of the any record, then you can use ID as the data type. Integer, a 32-bit number that does not include a decimal point. So this is basically a 32-bit whole number. Long, a 64-bit number without a decimal point. So if you feel that your number has or may have a decimal point, then use decimal or double. If you feel that it's going to be a whole number, then use integer or long. String, any set of characters surrounded by single quotes. So string is basically a set of characters. Date, a value that indicates a particular date. Date time, a value that indicates a particular day and time. Time, a value that indicates a particular time. So these are the basic primitives, all right, that you will be using. All right. So these are the data types. Okay. Now comes the S object. So primitives and all these things are very simple. So as I said, you just have to define something which is a set of characters. You can use string for that. If you have a whole number, then you can use integer, or a long for that. If you think that there can be a decimal point, you can actually use decimal p equals 36.48. Okay, so that's how it is, right? So these are the basic data types. Now, apart from these, we also need to deal with the records. Now, this entire Salesforce is all about records, right? And we need to deal with them very frequently. So now I need data types which can actually store complete records. So I also need variables where I can store full records. Let's say I need a variable for a complete account record. An account record has got number of employees, industry, website. So basically I need one variable to store all this information, right? So just to make things easier for us, Salesforce has defined another data type which is called S object. Okay. S object basically refers to Salesforce object. The term S object refers to any object that can be stored in Force.com platform database. So, or you can call it as Salesforce object. So that's the data type. All right. Now, an S object variable represents a complete row of data and can only be declared in Apex. So as I told you, S object is something which is only known to Apex. You cannot define an S object in any other programming language, right? So this is a data type, or this is a type of variable which can hold a complete the row of data, full record, right? So let's go ahead and see. Let's say I want to define a variable which can hold a complete account record. If you want to do that, all that you need to do is you have to define S object. Okay. Now for S object, you don't have to remember some of the data type names and all that. Like there we don't have like string, integers, stuff like that. For S object, if you want a variable to store complete account record, then the data type will be name of the object. We use name of the object as the data type, right? So I can say account A. Okay. When you say account A, this account A can be okay. So this account A, when I say this A is a variable which can hold a complete account record. Correct? So A is a variable which can now hold a complete account record. So if I say contact C, C is a variable which can hold a complete contact record. Now C cannot hold an account record because the data type is contact. It's that simple, right? So if you want to define a variable which can hold a complete opportunity record, you simply go and say opportunity and name of the variable can be anything, ABCD. Let me put it over. That's it. That's how simple it's going to be. Alright. So while defining these S object variables, you have to define the data type as the name of the S object. So data type is basically name of the object. Right? And your Apex program will understand that now this A should hold a complete account record. That's how simple it is. Alright. Now let's say account A equals new account and name equals IBM website equals account, phone equals right. So see, now account A is basically a variable of type account which can hold a complete account record, and here you can provide information about each and individual field. Right? That's how it is. That's how it works. Okay. Now, if you have to access an individual value from here, like if you just want to access the name of the account, so A is a complete record, right? Now, if I just want to access one individual field from here, A dot name should help you get the value of IBM, right? Or if you say A dot website, that will help you get the information of the website. Okay, so this is how it works. So this A is a complete record, and I always have the option of defining the variable name dot field name to access the value of a particular field from here. Right. So let's say if I just want to check if the website is there or not, so I can write it like this: if A dot website not equals blank. Okay. So if you want to access value from one particular field, then you can always write it this way. Alright. So this is how we can actually define our S object, and we can access the values from an S object record by using this syntax. The variable name dot field name. Correct. Now this is one way of supplying the value for account. So this is applicable if I'm talking about a new account record. Okay, there's an account record which is not there in the database. You are supplying the value from your side. This is the way to do it. All right. Now let's assume that I have got a record and I want to get the value of that record. I have got a record in the database and I want to get the value of that record in my variable. Then you can write a query here. You can write a select statement. Select name, type, industry from account where d equals okay, that's it. This is it. Right. Now this second example is gonna this one is gonna retrieve the information from the database and supply it to this variable. Right. So if you already have the data in the database, then you're gonna write a select statement for that. You want to retrieve it, you can always write a select query or a select statement to fetch the value. Right. If you feel that the data is not there in the database, you want to supply the values from your side, you can use this approach also. Alright, so that's how it works. Okay, so that's how we define S objects. Now we'll go to the collections part. Okay, so when we talk about collections, collection is basically we have three types of collections that we work with: a list, a set, and a map. Right. What is a list? What is a set? And what is a map? Let's understand it here. Yep. So in the data types, we talked about primitive as objects and collections. Under collections, I've got three types: list, set, and map. Okay, there are three types of collections. All right. Now, what is the difference between these three types of collections? Let's understand. So first of all, we'll talk about the list. What is a list? Okay. So before we get into talking about list, let's have a quick look into this collection of values. This is basically collection of string values. Okay, red, orange, yellow, green, blue, purple. Right. So this is a collection of string values. Right. If you notice there is an index number corresponding to each value. Can you see that? Red is index 0, orange is index 1. Okay. This kind of a collection is called a list, where every value in the list has got a corresponding index number. Got it? Every value in the list has got a corresponding index number. Okay? And because every value has got a corresponding index number, they are actually ordered in that, by that index number sequence. All right? Like this is the first value, this is the second value, this is the third value, this is the fourth value, right? So they are actually ordered in that particular manner, in that particular sequence. Got it? This kind of a collection is called a list. Okay. Okay. So a list is an ordered collection of primitives or S objects that are distinguished by their indices. Alright, this is basically refers to the index numbers. So what we are talking about here is this is an ordered collections. This is an ordered collection of primitives or S objects. So it can be collection of S object also, but don't worry about the S object for now. Let's just understand it with the primitive concept. Later on, we will look into S object thing also. So this is just this is basically an ordered collection of primitives, okay, and they are distinguished by their indices. So they are distinguished from each other by indices, the index numbers, okay, or In other words, I can say that they are identified by the index numbers and not by the value itself. That is very important to understand. Okay, so a list is an ordered collection. In this ordered collection, what happens? Every value has got an index number, and they are actually identified or distinguished based on the index numbers, which means this is the unique key for this value, right? Index number. Index number is basically the unique identifier for that value. So let me make it a little more simple for you guys. Let's say I am talking about list is defined like this. If you want to define a list of string, you define it like this. If you want to define a single string, you can define it like this. String color equals red. All right. Now, if you have to define a list of string, this is how it is defined. Let's say colors equals new list of string red, green, blue. Okay, now the concept of the list is that every value that gets into the list will get an index number assigned to it. So what is the index number that will be assigned to this? Red. Starting from index 0. So what is the index number which will be assigned to red? 0, right? What is the index number that will be assigned to green? 1, right? What is the index number assigned to blue? Index number 2, right? Okay. Now these values are distinguished and they are identified by the index numbers, which will mean that if I have, try and understand this, important. If I have one more value here, one more red here, do you think it's going to consider this red and this red as duplicate, or it is going to consider them as unique? Two unique values. Do you think this and this will get considered as duplicate values, or they will be considered as unique values? They'll be considered as unique values. Why? Because they are basically being distinguished based on the index number. It has got index 0 and this one has index 3. Correct? So they can be repeat of the same value. That is permitted. Right? So that's the attribute of the list. Now if you have to fetch a record, you can fetch it based on this. Colors dot get 2. Okay, so I'm actually fetching it based on the index number again, right? What do you think? What will this return? Colors dot get 2. What value it's going to return? It's going to return blue, right? Okay. So that is the concept. So every value that is getting into the list has got an index number. Duplicate values will be allowed because things are, the values are being identified based on the index number, and every value will definitely have a different index number. You can retrieve the values using the index number. All right, so you can actually retrieve the values using the index numbers. All right, so the values which are getting into the list, they can be retrieved at any point of time using the index number. Right, so that's possible. All right. Okay, so now I'm going to talk about a few more functions that you can use with a list. Like if I have to retrieve value of a particular index number, I can use the get. If you have to add a value, and if you have to set a value, if you have to clear the list, these are the things. Okay, there's a different example given here with integer. I'll just try to convert that into the string thing because we are talking about that example, so I'm going to use that. Right? So I'm not getting that. So if you have to add one more value, you can just go and say colors dot add, and you can say pink. Now what do you think is going to become the index number of pink? Basically I'm adding one more value to this list. So what will be the value assigned to pink? The index number 0, 1, 2, 3, 4. Right, index number 4. So pink will get added. So if you have already defined a list and later on you feel like adding one more value, you can obviously go and do this. Colors dot add. Right. Or you can say, if I have one more list of sorry, if I have got to add 4 5 more values, list of string colors 2 equals black, brown, right? So I have got another list called colors 2. I want to add all these values to this list. I can obviously go and say colors dot add colors 2. Correct. So this way you can add one list into the other list and all that stuff. All right. If you have to set the value of one particular index number, index 1 is green. I just want to set it to purple. So I will just go and say colors dot set index 1, set it to purple. Correct. So this way we can actually set the index numbers and we can retrieve the values from here. All right. Okay. So that's about the list. All right. So here every value has got an index number. Now we come into another collection. Take this example. Here the values are there. I can see a collection, but I do not have an index number associated with each value. Every value is independent. It is not associated with any particular index number, which means that the value itself is the identifier. Okay, the values are basically distinguished based on the value itself, right? So if you have one more Paris here, that will become a duplicate of that, and only one value will remain, not both of them. In the list, both of them could stay because they were being distinguished by the index numbers. Index numbers were different. But in this case, if I have one more Paris, ultimately I will just have one Paris stored and the other one will automatically get deleted because that will be considered a duplicate, right? So that is it. So a set is an unordered collection of primitives or S objects that do not contain any duplicates. So this will not contain duplicate. In list you have a provision of allowing duplicates. In set you do not have a provision of allowing duplicates. All right. So set is defined pretty much like same way. Just that instead of list you are going to use the word set. If I say this, let me call it weekdays. Okay, set of string weekdays. And I say new set of string Monday, Tuesday, I put one more Monday and then I put Wednesday. Right, if I put this, ultimately only 3 values are going to get stored in this variable weekdays. Monday, Tuesday and Wednesday. Because this is a duplicate. Right, there is no concept of index number. So the records are being identified or they are being distinguished based on the value itself, and that's the reason why this will be considered as a duplicate and it will be removed. Only 3 of them will get stored. Got it? So that's how it is. You want to add one more values, you can always go and say weekdays.add the same way. You can add Thursday to this. Okay, you want to remove a value, you can go and say weekdays dot remove Tuesday. Okay, you can do that. All right. Or if you want to check, just go and check whether a value is present in this or not. I just want to check in this weekdays list, do I have a Friday also? So I can always go and say uh, weekdays just one quick moment, I'll just quickly check the syntax. Yeah. So we've got a method called system.assert, and here I can say weekdays.contain Friday or not. This is basically going to return a true or false. If this weekdays contains a Friday, then it's going to return a true. So this is basically returning a boolean here. Alright. Boolean is the data type, right? True or false it will return. So that is how it is. Got it? That's how it works. So that's the concept of the set. Alright. Now the third type of collection, which is map. So we have got a list, we have got a map. We have got a list, we have got a set. Now we are going to talk about the third type, which is a map. What is a map? Map is basically collection of key value pairs. Okay, a map is a collection of key value pairs where each unique key maps to a single value. Collection of key value pairs means let's try and understand it this way. Let's say I want to have a collection where I have got list of countries and the currencies of those countries. Okay, so I just don't see, if you just want to list countries, then you can have just a single list of countries or set of countries. That's fine. But here I have got key value pair. So I basically want to store the pairs. Key value pair. So this is collection of a key and a value. Okay, there's a key and there's a value corresponding to the key. Okay, so let's say we have got this list. US currency is USD. India INR. Australia AUD. Okay. Now this is what I want to store. Okay, this is what I want to store in the collection. This is where you need a map. Alright, so the left hand side of the pair is called key and the right hand side is a value. Alright, this has to be unique. The key has to be unique. Alright, so you cannot have one repeat of the key here. I cannot have US one more time, but I can have USD one more time. Let's say, just for example, let's say the currency used in Canada is also USD. So the value can be repeated. Okay, but key cannot be repeated. Alright, so the unique side is basically the key and value can be repeated. There's no problem with that. Correct? So this is called a map. If you understand, map is pretty much similar to list. List is also key value pair, but in list by default the key is the index number. Index 0, index 1, right? Corresponding to each index number there was a value, right? And value can be duplicated as I said. Right? So index numbers were unique, 0, 1, 2, 3. Value can be repeated if you see red right here. Map is pretty much on the lines of a list, but just that instead of using the index number as the key, as the identifier, you are defining as your own customized identifier, which can be confusing, right? Because if you see with the list, if I have to fetch a value, always fetching it based on the index number might be difficult. You might not know what exactly index number you have to fetch, right? The value is in index 3 or index 4. Map will actually give you the values, customized value for that. So if you want to fetch the currency of India, you can simply go and say get currencies from India, right? So you can actually use this key value. It's easier to use, right? So that is how it is. How do we define that? To define a map, it's pretty simple. All that we need to do is we will need to use this thing, map string, and string is the syntax, which I call it currencies equals new map of string with string, and this is where you have to define it. So just quickly copy paste this thing. Few brackets and all will be required. I'll just put that. Okay, so this is the first key value pair. Then put a comma, then put the second key value pair. Put a comma, then put the third key value pair. Okay, so this is how it is defined. Let's put it in the second line. Okay, fine. So let's say that like this is how it will be defined. All right. Now, since you have defined the key value pairs, you have the option of getting the values by using the name of the key. So you can say currencies dot get India. Okay, or you can say more string client country equals India, and here you can say client country. Alright, so what do you think this is going to return? Currencies.get. What do you think this is going to return? Look into the code and let me know what will it return. It's going to return Indian currency, right? INR. Right. That's how it will work. Right. A few more things which we can do with it. If I want to add one more key value pair, here you have to use currencies dot put. Okay, and you can put the key value pair like France euro. Okay, so if you want to add one more value, the key value pair, so this is how it can be added using the put method. Right, you want to check if a particular key is already there or not, you can just do the system.assert. Right, and check if currencies dot contains key US. Right, or if you want to check if you want to check if a certain value is equal to the one that we have in the value or not, I mean in the map or not, then we can always go and check using system dot assert equals, and we can actually enter a value, let's say INR. String here, client currency. Okay, and this client currency is equals to currencies dot this. Okay, so I have defined a variable, string variable client currency. Now this client currency is the currency of the current client, and I want to check if this is equal to INR or not. Okay, the system.assert equals will return a true. This is a boolean, it's going to return a true if the client currency is equal to INR. So that's how it is. Got it? So this is how a map is defined. Right? So these are the data types which we're going to deal with, and all the programs that we write, we are going to use these data types. So once we start working on the codes, and once we start writing programs, things will become a little more clear to you guys, right? Okay, so that's what we are going to do today. Tomorrow once we meet, we will talk a bit about the classes and the methods, because just knowing the data type is not enough to write a program. You will also need to understand a couple of more concepts, and then we will straight away start creating our Visual Force custom controllers. All right. Okay, now let me know if anyone has a question or doubt.